The first thing that we're going to need is the merge sort function. So let's write the merge sort function. And the merge sort function will always take the array, the beginning index, and the end index. Okay? Now, since this problem is recursive in nature, we're going to keep dividing every array into two subarrays using a recursive function. So the first thing we have to do is to find the middle of the array, because if we have an array to divide into two sub-chunks, then we have to find the index of the middle. We know the beginning, we know the end, we have to know the middle. So the middle is just the beginning plus the end divided by 2. Okay? So let's do that. Let's write that. So the middle is the beginning plus the end divided by 2. And of course, this is the Euclidean division. Okay? There is no, it's an index, it's an integer. There's no floating points here. Okay? And we're going to call the same subproblem. So that's, let's free up some room here. So we're going to call merge sort. So the function is calling itself. We're going to call the merge sort for array, but for the left subarray. So the index of the indices of the left subarray would be the beginning up to m. Okay? So we're going to do the same thing for the beginning up to m. And for the right subarray, we're going to call from m plus 1, that's the middle plus 1, up to the end. Okay? So these two instructions are what's going to split the array into smaller chunks until we get chunks of size 1. Okay? And then after that, we're going to call the merge function. The merge will basically takes the beginning and the end of the array. It will divide the array into two subparts. So if we gave it, this is the beginning and this is the end, it'll divide the array into half, and then it'll merge the first and the second part together to get a sorted array. All right. Now, of course, we said that the merge sort would keep dividing the array until we get until we reach arrays of size 1. For that reason, we have to add an if statement here. So if the beginning equals the end, then basically we have to return. Okay? We have nothing else to do. We just return. We just quit. We do not execute these instructions anymore. Okay. And basically that's it. That's for the merge sort. So this is the merge sort function. Okay. Now, the only thing that we have to mention here or to code here is the merge part. Okay. So the merge function, let's just code it. Okay. So we have a function called merge that takes an array, and we know the beginning index of the array, and we know the end index of the array. So basically the first thing, let's compute the middle element. So m equals the beginning plus the end divided by 2. And then the second thing we have to do is we're going to create a temporary array. So let's create a temporary array. So temp array. And the temporary array size would be the end minus the beginning plus 1. Okay, we only need end minus beginning elements. So if, for example, we're merging from 7 up to 10, for example, then we need the element number 7, the element number 8, number 9, number 10. So that's 10 minus 7 plus 1. So that's 4. Okay? So that's the AND minus the begin and plus 4. All right. Now that we have a temporary array, we need to create the k counter. The k would always keep track of the elements added so far to this temporary array. So k takes 0 initially. And then we have to copy the elements from the original array to the temporary array, but in order. Okay, they need to be copied in a way that they are kept sorted. Okay. So let's create the I variable. So we said that I takes the beginning, and j takes the middle plus 1. And while I is less than or equals to m, and j is less than or equals to end, we're going to do the following. The following is basically we're going to compare. So if the element number I, array of I, is less than array of j, it means that the array of I is smaller. So we have to place array of I inside the temporary array. Okay? So let's do that. So temporary array, so temp r of k takes array of I. But of course, whenever we add an element to the temporary array, we have to increment it. So here we have k++, and whenever we read an element using the I counter, we have to increment I, because that element has been already copied. So we increment I. Otherwise, if array of I is less than array of j, then array of j is less than array of I. So we have to copy array of j instead. So tmpr of k++ would take the array of j++. Okay? So that would always take the smaller element between the elements pointed by I and the elements pointed by j and copy it inside the temporary array. Now here the only thing remaining is that sometimes one subarray is finished while the other is not finished. Okay? So for example, let's say we took all the elements pointed by j reaches the end of the array, while I still has a bunch of elements. Okay? In that case, in that scenario, basically we have to copy the rest of the elements. Okay? So let's do that. Let's do another while. So while I is less than or equals to m, it means that I didn't reach all the elements yet, even though we completed the first while, yet I is still has not still yet reached m. It means that we have a bunch of elements that we have not copied yet. So let's copy them. So tmp of array, temporary array of k++ will take array of I++. Okay? And another while to copy the elements, if any, of j. So if j is less than or equals to m, then the temporary array of k++ would take the array of j++. Okay? And now we're sure that we have all the elements. We have all the elements merged inside the temporary array. Now we have two arrays. Well, now what we did so far is that we have an array. We created another array called tmp array, and we started merging inside the new array, the temporary array. So the final thing to do is to copy the result back to the original array. We have the elements sorted, we have to copy them back. So let's do that. So to copy the element back, all we have to do is to loop through the temporary array and copy its element inside the array again. So let's use the variable I since we're not interested in it anymore. So we're not going to use I. So for I starts at 0 up to k. Remember, k is the size of the temporary array, okay? Because k in the previous iterations will stop at how many numbers we added to the temporary array. So now it is the size of the array. So for I starts at 0 up to k. Every time we're going to copy. So we're going to copy the temporary array of k. So the element number k inside the temporary array, we're going to copy that inside the array. Okay? At index the beginning plus I. Okay? So we always copy at the index the beginning at offset I. Okay? So if the beginning, for example, is 3, then we're going to copy temp array of 0 to 3, and then temp array of 1 to 4, and then temp array of 2 to 5, and so on. So 2 to 4, something like this, 0 to 4, 1 to 5, 2 to 6. So there is an offset here. Okay, there's a difference, 0 to 4, and 4 is the beginning. Okay, something like that, okay? But you got the idea. So after that for loop, we basically have merged the two arrays. Okay, so we got an array, we split the array into two halves. We know that two halves, every one of them is sorted, and so we merge them together, and then we copy the result back to the original location. And basically that's the merge function. Okay, so let's try to code this and then see whether it works or not.